Oh. Yeah. Okay, you still have all this graphs from last week, right?
Yeah.
Okay, good. Anyway, just to recap, for distance time, the thing to recall is it must be an increasing graph. It cannot decrease. If you ever draw decreasing, something is wrong. Okay, and make sure you realize the gradient is the speed. Then the other graph is speed time, which you have gone through. Now, speed time can decrease, but it cannot go below 0. There's no such thing as negative speed. And again, a reminder, technically, speed and distance are scalars. Hopefully you remember that word. Oh, you forgot what it means. So distance, speed are scalars. Yeah, what is scalar?
Is it magnitude?
Yeah, magnitude only.
Don't got direction.
Vectors. You may have a one MCQ question or one mark question on it.
First question, right?
Yeah. So make sure you can differentiate scalars versus vectors.
You have to ask the diameter of the earth.
Yeah, sometimes.
You cannot I can't remember.
One the diameter.
No, the thing is you don't remember so much. Just remember the okay. How big is Singapore? The most longer is 40 kilometers, right? Then how big is USA? Don't know.
I do not even think this is a thing. They asked me my atom also.
It's about a few thousand kilometers. So how big can the Earth be? At most tens of thousands of kilometers. That's how I remember that. Not that big. It's just what it is. Like USA is only about 3,000 kilometers wide.
Only?
Yeah, only. So how big is Earth? At most thousands of kilometers. I mean, not thousands, tens of thousands. So the diameter will be about there, tens of thousands.
But they gave us answer so similar. So same one.
No, it won't be the same. It'll be like a few thousand, a few tens of thousands, a few hundred thousands.
No, like this is something number times 10 to the power of maybe the answer is 7, right? Then you put 6 and 7. Then I'll be like, is it 6 or 7? Now we get the equation wrong.
You know, get to know tens of thousands is how many meters? Tens of thousands kilometers. I just remember there, tens of thousands. Diameter is about there.
Atom.
Atom.
The small one.
Negative 20.
No. What's the smallest number? I mean, what's the smallest length? You know, from micro to nano, then to pico, right? But basically, at nano, you can more or less see the molecules already. So it's about there. Nano and then one order smaller. Nano is 10 to the power of minus. Okay, cannot remember. I thought we did it last week.
Me?
Yeah.
12.
No, nano.
9.
Nano is 9. So atom is about actually smaller than nano, about 10 to the power minus 10. Minus 10, about minus 10. You never know, they may.
If you read the first one.
Yeah.
Then so it's second question.
But anyway, regarding kinematics, make sure you know what are the vectors. Displacement. Velocity. And by right, acceleration is counted as a vector.
It's magnitude. I mean magnitude. It's weight. Is it
It has magnitude and
what?
And what?
Action.
Yes.
Weight is vector. Weight is,
Weight is a force, right?
yeah,
Force as direction, right?
fine. It's wrong.
Okay, so since we're on this, yeah, make sure you realize all forces are vectors. All forces. Okay. Okay, now let's go back to our diagrams. So yep, make sure displacement sorry, distance and speed can never be negative. Distance cannot go down, cannot decrease. It must either increase or remain stationary. That's the important thing. Now, let's go to displacement. Displacement. Displacement can be negative. What's the meaning of negative displacement? No. Displacement doesn't tell direction. It tells you something else.
Other way.
Isn't it going back to the original?
Beyond the origin.
Correct. So the key point is displacement equals to 0 is the origin.
Oh,
Or, okay, the reference point means the position. Okay, let's step back for a moment. Displacement, think of it as position.
Oh.
It's not speed, obviously. It's not direction, it's the position.
This is my Chinese.
can I go attend?
Huh?
I go O level.
Well, that's not going to help you. It's for primary school only.
Anything works.
Anything works, I doubt so.
And then tomorrow they come out with 真爽.
真爽.
What? 厕所.
真爽.
Oh.
Hey, Kelvin, they need to write down, no? Displacement 0 means at reference point. Okay, displacement more than 0 or positive.
But I remember there was a period of time I wanted to go for Chinese tuition.
Oh.
And then I feel since it's then I'll go.
First. See, and I always mind.
Well, if it's positive, you can define it as to the right-hand side of the reference. Okay, right of the reference point. That also means displacement negative means left-hand side.
Oh.
But it can also easily mean positive is up, negative is below.
Oh, yeah.
That's possible too.
So you're about to read. You're about to read.
Oh. Got so many now. Go and see like all the words that I actually have.
Oh, okay. What else?
What else? What accelerating?
Displacement time. How about the gradient of the curve?
Accelerating.
Huh?
Wait,
No?
I don't remember.
Displacement time is velocity.
And you assume what's under the door.
Okay, so take note. All right, because displacement and velocity are vectors, so one will lead to the other. Gradient of displacement time graph will give you velocity. Because both are vectors. Okay, on the other hand, just now what did we mention? Distance, speed, right? If I get the gradient of distance time graph, that will give you speed because both of them are vectors. Okay, both of them are scalars. So
It's not on the side.
then, wow, that won't come out, but then it will be a very different story already. Or in the very, very rare case, they'll give you like against energy. Those are very difficult questions. Very difficult.
Can imagine.
Yeah, they'll plot energy against displacement. Energy against velocity. Those are difficult ones.
So you need energy to go negative is vector is
Energy cannot be negative anyway. Remember, energy is a vector scalar.
like
Yeah, of course it's a scalar.
so it increase energy.
So it's
Yeah.
So it's zero.
Yeah, how does the energy curve look like? Increasing like that, straight line like that, or what? That's the difficult part. Those are difficult questions that comes up rarely.
It's increasing and decreasing rate. I don't know what is that.
Anyway, back here. Okay, so I can have this, better be able to describe now if I tell you something like this. So what is happening? How's describe the motion of the object? Move to the right, then it U-turn, go backwards, and then move to the left of the reference point.
Yeah.
But of course, you have to describe more than that. You also describe the gradient. What's happening in the gradient? Constant, yes. Okay, to a certain extent, constant. Constant, then decrease, decrease, decrease until, I hope you notice this point is zero gradient. What does it mean? Zero gradient. Yes, velocity is zero. And that means it's at rest. Can make sure you can catch that implication.
Yes.
At rest for only an instant before it reverses backwards.
Right now it is right.
I may in the future.
So,
oh,
Okay, and of course, make sure you realize this is the point of reversal. So point of turning back, like if you want.
turning point.
Yeah, turning point. Point of turning back. Depending is up, down, or left, right. How about this point? What does this point mean? This point?
Is that the
original.
Yes, back to the original point or back to the reference point. Okay, and then it go past the reference point. Okay, I shall not dwell too much on this.
Am I wrong? I thought 单是在跟你提手旁。
What?
单是的单。
Yeah, it should be. It is.
I think wrong. Oh. What? I'm starting to worry my own Chinese.
Yeah, you got A1 already.
Correct what? It should be this one.
Okay, Gang, the one that's likely to come out is velocity time. Okay, same thing. I was going to ask you, what if velocity is zero? I think we have the answer already. It means stop at rest. But I'll write it down nevertheless. What if velocity is positive?
It is increasing.
No, not necessarily. It means your object is moving in the positive direction, or let's say to the right.
Okay.
Okay? Take note. Positive velocity means it's moving in one particular direction, in the positive direction, maybe to the right. But of course, you must know what's negative velocity. Okay, that means it's moving to the left. Counting. What does the gradient of the curve mean? Yes. Now, of course, you better notice if the gradient is negative. You better know what's meant by negative gradient. What does that mean? Negative gradient means acceleration is negative. That means it's decelerating or deceleration.
Yeah. Okay, okay.
It doesn't mean acceleration is decreasing, it means it's decelerating.
Okay.
Good. So same thing if I give you something like this. What does this mean? Now, look at the whole portion here. The positive portion. This whole portion is positive, right? So basically for this whole portion, it's still moving to the right. I mean, assuming right is positive, it's still moving to the right. But what happens at this point, this point? Does it turn back? No, it's still moving to the right. Does it stop? No, it doesn't stop. What is happening at this point?
Because it's speed.
You can say that, but how to say constant velocity when it's a point? At any point, it's also constant velocity in that case.
Velocity.
Okay, fine. Maximum velocity. Now, actually, I'm asking a trick question. Let's step back and look carefully. Look at this part of the curve. What's the gradient like? Positive, right?
Oh.
Positive gradient, right? That means it's accelerating. Speed is increasing. So let me write it in.
I feel like practical.
Practical? What practical? Okay, let me, okay, I can use speed is increasing. But of particular interest is this part. Now, Ming-Ting, tell me this portion here, what's happening in the gradient? It's a negative gradient, no? Make sure you write this down, negative gradient. Negative gradient means, what did we say just now? Yes, deceleration. So speed increase, slow down. Yes, slowing down. So this is negative gradient. Make sure you know what is positive and negative gradient. So slowing down, but it's still moving to the right. Slowing down, or what we call decelerating.
So what we change direction?
Yeah, when does it change direction? When your velocity is negative. So when does it change direction? At which point? Good. Come, Jingjie, this answer here. This is the point. This point, that point is where it changes direction.
Okay, I'll take note of it.
Not only that, this point is also velocity is 0. That means it stops for that moment. Just for a moment, an instant, before it reverses. Just one last thing. What about this final portion? Let me use a different color. How about this final portion here? Yeah, opposite direction, right? But it's also speeding up, no? It's speeding up in the opposite direction. Can make sure you can say something like that. Yeah. Speeds up.
No job.
Yeah.
Because my velocities become more and more negative. That means it's moving faster and faster in the opposite direction to the left, let's say.
Oh yeah, oh my gosh.
Speeding up to the left. It means if you take the opposite direction as left.
Swimming doesn't have much.
Math. Better than nothing, right? But there's an important thing about velocity time curve because the area also tells you something. Yes, good. Not distance. It tells you displacement. So this area is displacement. This area is displacement.
Area underground.
Yeah. Let me put it in. Area is displacement. Okay, then right, I don't think I want to give you the difficult ones. Yeah, I know I even come up. I don't think it's gonna come out, so I give you a simple one. Okay, last graph. Acceleration. Come, let's have some fun. Based on this graph, draw the acceleration time graph. No, I didn't draw anything there. Then I didn't draw it.
Hello.
Yeah, that's the house. Cannot start from zero, right?
Are you sure it start from 0?
Cannot start from zero, right?
Yeah, cannot.
Okay.
Because look at time 0. Is there acceleration? Is there gradient? There is no. There's an initial gradient.
I know drawing. There's much. I never know. Should be.
Yeah, there is an initial gradient here, this thingy here. So it's not 0 acceleration.
Oh, you're
Where
right.
which one?
It's like that.
So,
It is?
No. Okay. Reminder, acceleration is a vector.
oh,
So it can be negative.
so it went down.
It can be negative, right? Acceleration.
Oh, because, oh. Wow.
Just draw.
Alisa.
Just draw.
Have you? No?
Small.
Okay, come, guys. How to analyze it? Look at this curve. First thing first, check the gradient. Did you notice this whole chunk here? Okay, let me use a different color. Let's say purple. This whole chunk here is negative gradient. Right? So a negative gradient means negative acceleration. So my value should be below the x-axis, right? Okay, on the other hand, I was telling him, do you have initial acceleration? Yeah, you do know. There's an initial gradient here. So that means this is the initial acceleration. Meaning that it doesn't start from 0. Is it positive or negative? Yeah, look at this blue portion here. It's positive gradient, right? So that means your acceleration must be above x-axis.
So it goes up.
Okay, let's make it even more difficult. Your acceleration is your velocity is yeah.
Oh, like, I don't know.
But look at the gradient. Is the gradient increasing or decreasing? Sorry, decreasing. Decreasing. Yeah.
Decreasing.
Yeah, it's decreasing. So, okay, let's have a value for this point. This is an important point. Let's call this time t1. And you notice this point, what's the gradient? Yeah, t1. This point, what's the gradient?
Oh.
Yes, good. 0. Meaning what? Acceleration is 0 too.
Yeah, so.
So how does it look like?
Yeah, I don't know.
Yeah, something like that, but it could also, I mean, without doing any mathematical calculation, it could also be a straight line. So this is,
Straight line.
no, you don't know, unless you do calculation. Unless you know the equation.
Hey, it's that.
Oh, shit.
Huh? So it's going to look like this.
Yeah.
Yeah, something like this. But of course, it can be a curve too, like you won't know for sure.
So it's the truth.
Mm. Okay, no, yeah, just like that. Yeah. Hopefully it doesn't come out. But if you look at the acceleration time curve, what does the area under the curve mean? Yes, good.
What?
Velocity.
Actually.
Yeah.
Huh?
Hopefully it doesn't come out.
Oh yeah, so it's a measure.
Yeah, you may have to. But just pray that it doesn't come out. Okay. Yeah. Oh, by the way, kinematics has only one equation. What's the equation? Or one formula?
I know it's initial velocity over time is acceleration.
Okay, good. Come, write this down.
B U of I.
E, U, and T.
Really?
Yeah, that's all.
I thought it's
Final velocity. U is initial velocity. Yeah, so good. Only one formula for kinematics. Yeah, sure. But the only thing to remember is this. This only works if what?
If
Yes. So you better double check acceleration is constant, right? Actually, there's one more formula, but the other formula is a primary school formula, so it's not counted here. Yeah, average speed. What's the formula for average speed? Total distance over total time, including stop times and pause times and so on.
yeah.
You see, kinematics is doable.
no until you look at the question.
Then you get stuck.
Yeah.
So I'll give you some questions.
Hi, yeah. There is still and Papa share for 10 minutes.
变一个面，你刚才那个左边
Oh, the ring calculator.
哎呦，
Ah.
What we do? Huh?
Yes. Diagonal.
妈妈，是呀，按住长按长点，
Temperature. Oh,
那个
this look very.
yeah, it looks special.
Very old, right?
边
Yeah, O2.
So vintage.
So visual.
哦哦哦哦，
Before the show particularly that works. At one point, we can research in family. How we were, how would it get zero speed? But
Down.
so it's accelerating at first, is it?
Huh? Which one?
3.
Let's see, 3.
What?
So like it is like this.
What are you drawing? What axis? Huh? Acceleration? No. They already said decelerate uniformly. So as the speed is decreasing.
凹
It is
Okay.
exact.
But not exactly also. Look at the. No, do you notice the deceleration is uniform? What does it mean?
Straight.
Straight line, right?
I say straight there, right? Oh, yes, amazing.
这些坏了六，
How about the turn upwards one?
这样一个角
Yeah, turn outwards. Good. So how do you draw the curve?
要切角，
Straight up, straight down.
Okay, let's see. What curve are you drawing first? Velocity, right? Let's say you want velocity, yeah?
头切角，
So that means at first when it started, does it have velocity? Yeah, it does, right? 1.2, right? So my 1.2 must be here. Right?
换了
Okay.
Then what happens to velocity? Is it decreasing or increasing?
换，
Yeah, they told you it's decelerating. So it decrease, go downwards in a straight line until zero velocity. Then what happens after that? It goes upwards, right?
Yeah.
It's still moving upwards until it just stop there for an instant, then it will move downwards, right? So that means it now velocity becomes negative.
哦，这个
So this is
这
the
个
highest point when velocity is 0.
你看呀，
Oh.
Okay, must really know this. So how long does it take to reach zero speed?
它
And
它这里按
what does the value even have?
Well, there's only one formula to use, remember?
Okay. So it's a final Final velocity.
V minus U over T.
V minus 1.2 over T equals to 10.
Now, remember what is my positive direction, up or down?
Wow.
Let's-
What?
which direction is positive, up or down? Let's take it as up, huh? So therefore, is your acceleration upwards or downwards? That's the difficult part. Downwards, it's downwards. That means my acceleration is minus 10. What's my final velocity? V? This is 0 speed.
Yes.
So that is my final velocity. What's my initial? 1.2. Then find out my T.
First.
Done. Are you sure you get it?
Yeah, I did.
Okay, good.
Conversion.
What did you get?
Is it?
Hmm?
Is it?
Yeah. So you must get it. In fact, all the questions you have to get it right.
The sky coming down the slope of a snowy mountain. The acceleration in the hot snow and single speed is going to get us again. Emotional engagement and happiness. Snow. 那 what's the answer, please?
5.
Yeah. You tell me, teacher.
Let's ask Jingqie.
It's
Number 5.
5.
Oh, haven't done.
Oh, what?
Okay, come. Thinking, do you get this? Okay, easier.
Average speed. Total distance traveled per unit time.
Over total time.
Over total time. But you are always say per unit time.
No, you can't really say that because you have to include all the stop times and so on.
Total distance over total time.
Yeah.
Take good.
How, Jingqie, okay, can understand the answer?
Yeah.
Yeah.
8 to 6 p.m. It took 12 hours.
Yeah. Because they drive for many kilometers.
It started from point A at 6 a.m. Where's 8? Okay. And then we went to B until A again at 6 p.m. Okay. Wait, average speed from A to B. A to B. 9 a.m. So it took 3 hours. Right?
Yeah.
So the average speed is 10 divided by 3 lah.
Fine, can I just write the formula?
Can, but try to use words to express the formula.
Yeah, total distance divided by total.
Yeah, that's it.
Yeah.
Okay.
Yeah, I don't write.
Don't run.
Now I
You better remember it.
Huh? You know, have this,
10 into 11 into 12, 3 hours. That is 8 divided 3. 2.67. Okay. For the whole journey. So total 10 km plus 8 km plus 7 km plus 12 km. Total time 12 hours. And okay. The trigger instrument is actually the shows that there is a lot of it. Decelerating. 10 seconds. The move should put in the train station. Times. What's the question? Average. I would say that in section should be. Which is fine. How it's just me. It's just maybe the acceleration will follow in the first 10 seconds.
给哥好，再问你啊。OK，哥，这个哦，
是你要不对对
你什么什么？
落
啊，第三，第三个，我都我什么是降落伞？降落伞是。direction。降落伞。我们大概是哪一个降？
To convert seconds.
For which one?
Question
Question?
1, section B.
Oh, convert to seconds. Well, they didn't say that, so actually you don't have to. So we can still use kilometers per hour.
Oh, yeah.
But it's okay.
Kilometers per hour.
This is still have to be. Still doing small. Okay, tell me the answer for BI. I can't see.
Number 3.
Oh,
Number 3, obtain the speed when 3 equals to 10 is 7.522.
can't see.
Oh, is it? You don't see it. Actually, it's 22.5. But there's a trick to it, no? I don't know whether you know the trick or not. Don't know, right?
Yeah.
Ah.
I don't use the.
But there's another trick also that you can use. Look at it. Now, you look carefully at this. So 45 is this point, right? 45 seconds.
Yeah.
37 seconds is the starting point. What is the middle? Middle point is at 37.5 seconds, right? Correct. So it's a straight line. Therefore, the middle point of the time corresponds to the middle point of the speed as well. The top speed is what? 45.
45 to 0 lah.
Yeah, and what's the middle?
2.5.
Yeah, so that's the answer. Because it's a straight line, so that one can work.
Carried by the body, say T30 is T45. Half times 45 times 15.
Oh, well, you should know this one, basic area triangle.
5 times
Yeah, yeah.
67.5. Describe the motion.
Now use rise overrun.
Rise overrun.
I don't want the gradient from 2 100.
Okay, do you understand what is rise or not?
It is.
Okay, let's say this is your slide and you want to find, let's make it even more challenging. If this is your curve, you want to find this point, then you have to draw the tangent.
This is
Rise overrun.
the math.
Use the math formula.
Lazy lah.
It is increasing. That's all.
Which one? Part 1. Yep.
What is acceleration concern?
Yeah, you should say that if you can.
Which
But it's not. So therefore, you have to be very specific. Acceleration is constant until 5 seconds. Then the acceleration decreases from 5 to 10 seconds. By right, you should say that. By right.
what you say?
How? Poverty, go on.
Cheap myself for
For what?
O level.
I thought you trick only after O levels.
That I don't know.
Boost your morale.
Ah,
Okay lah, then go boost your morale.
So acceleration is 0 like?
Huh?
The acceleration is what?
At which point?
After 5 seconds.
After 5 seconds, acceleration decreases. Then decreases to 0 between 5 and 10 seconds. By right, you should write that by right. Because gradient becomes 0 at 10 seconds.
From 5 to 10 seconds, acceleration decreases to 0. That's already for 1. How am I going to do for B? Okay,
Well, it's the same pattern. Now.
C is decreasing while acceleration is decelerating.
For B, right? 10 to 15. But that one is easy, but 10 to 15, what's happening?
The speed is decreasing while acceleration is.
You're talking about part B or part C? B is the speed changing?
Oh no!
It's not, yeah.
No, I was looking at
It's
the
okay.
B.
Yeah, draw here. But I was telling her a trick just now. You didn't manage to get it, is it? Oh, you want to hear the trick?
The speed is constant. Then
Acceleration is
okay.
speed constant means acceleration is
0.
zero. Okay, don't get confused. I was telling her the trick. So look at here. This point is what? 30, right? Coordinates 30, 45. Then the end point here is what? 45, 0, right? Correct? Yeah. So you're interested in the midpoint, which is somewhere here. So what is the x coordinates? Midpoint will be 37.5, right?
Oh.
Which is what the question was, right? So therefore, your y coordinate must be also the midpoint, right? Which is 22.5.
Where does one? Oh, B2.
Yeah, it's right at the midpoint. Remember your coordinate geometry?
Okay. Then you find you think this one.
Up to you.
Or you find, or you draw, then you find.
Draw, then you find. Draw, then you find. But the thing is, sometimes the graph is not very clear, so you may get
Find the point.
Actually, it's up to you. If you draw and find, it's not accurate, probably they won't penalize it.
What would you?
Me? Yeah. Probably I'll just draw and find. It's easier to visualize. And right, you learn about midpoint, right? Coordinates for midpoint. Still not to use.
No, I don't know.
Oh,
30 to 35 is the speed is decreasing, and this acceleration is increasing or decreasing.
30 to 35 is here, right? Speed is decreasing, right? Okay. Acceleration.
This acceleration.
No, this deceleration.
Yeah.
So at first, this is high deceleration. Then the deceleration becomes
So
less. Deceleration is decreasing. Yeah. Just put deceleration is decreasing. Don't put decreasing rate.
Comment the motion on the sheet and paper. The motion is accelerating.
Sorry, again. Number 5.
Yeah.
Release from rest in vacuum.
Just go.
But did they say that there is no gravitational force?
No.
No, right. So there's still gravitational force.
So you'll be accelerating.
Yeah. Under gravitational acceleration.
So I just say the paper will accelerate.
Mm-hmm.
That's all.
Not only that. Okay, come. When they ask about motion, you must talk about speed.
Oh, that's the
You must talk about acceleration. Yeah.
pen, right?
Yeah. Okay. Do you hear him?
Then
That means the speed is increasing, right?
yeah.
At constant acceleration. Or if you want to be kiasu, then you just put at constant gravitational acceleration. But you can write what he said also at acceleration of 10 meter per second squared.
Because air,
So it's only under gravitational force.
So speed is constant.
Speed is increasing. You need tissue paper now. Okay. You have you need more.
I tested all of every price.
But it's okay because the distance is so short. You won't see the difference. The distance is short already.
Then you go see the lesson plane.
Yeah.
My child go make science lesson out of it.
How to make physics lesson.
I should see what it is.
Big time graph.
Sudden average drop 1,800 meters. And then like as plane drop, passengers still in the air due to inertia. Then still vaccine.
Yeah.
Wow.
Yeah, it's not wrong. Huh? What? Check answer.
We have never done. I mean like
Then
the drawing.
yeah lor. Too easy.
Alright.
Hold on, you're drawing which one?
Big time graph. I thought you say speed is decreasing.
No. Because as it goes downward, it becomes faster and faster, right? Is it dropping or not? Imagine you dropping in mid-air, you drop faster and faster, so speed is increasing.
Did you say decreasing?
Oh no, I probably heard you wrongly. Speed is increasing, but acceleration is acceleration is
Constant.
yeah constant.
So it's just straight line now.
Yeah. Yeah. Okay.
Using graph paper. I don't got.
Never mind. I give you graph paper. No need to pay now.
I don't want to draw.
You ask for it. Then.
Yeah, it is. They can last for many years.
Oh. Well, it go back again.
Yeah, got free graph.
In Rome.
Remember. Yeah, why?
Why?
Poorly drawn.
Are you?
I thought about that.
Is it?
Oh, the points don't align here to like try like
Yeah. Best to think by right you have. This one I don't know who drew it.
Are you?
Oh, so lazy.
Okay, well, very easy to draw graph. Oh yes.
It's Okay, I thought probably no one. Why 11? 11 don't make things hard.
They want to be fun.
It can come out in real exam.
Okay, can we not start from 0?
For this case, no. It's going to
Oh.
try to start from 0 unless it's so far away. Because it confuse you if you do.
This is odd skill, I tell you.
Upscale? No, won't be upscale.
What's the odds? The odds.
That means you got an odd number somewhere there at the end.
Oh.
Thought you mean yes.
Or maybe weird scale.
I know.
That's how my teacher say odd skill.
Upscale. What's an upscale?
Fast.
Like you know, 1 cm you put 3 units.
Yeah.
That's odd skill.
Yeah.
What should have said?
Yeah. So that means your interval is odd.
Yeah, that don't be easy.
Why do you do it using a landscape orientation? Okay, why not? Up to you, ma.
You never earlier.
Right.
Oh,
You
should use a landscape for this case because your x-axis is longer than your y-axis.
I didn't know it.
You can do that.
I can do like that.
No need. You can do that. You should.
nobody said that.
Um,
Nobody told me that.
I mean, why not? I mean, you have to be flexible.
So nice, my line. Hit the erase man. My turn is damn freaking straight graphs.
Yeah, I know. Some teachers are like that. They want everything to be nicely labeled.
You know, I just never write 0. Then my skill code is 1.
Make sure you label everything.
It's damn straight leh. Then I will best fit if really cannot, right? They won't let you pass.
my chemistry.
Yeah, your school. I know, I don't want to teach in your school.
Why
My
not?
school all Paikia.
My kid's school.
Then you don't have our school so.
Hey, but her school can be, I think her school is worse.
Yeah, I tell you before. So my chemistry got one. Oh, wait, no. I don't know if you can see.
Just see lah. So you know it.
So right, she takes 7 class, but then got one day right, she never come to class. Like in my class. Then we all wonder what happened to her. Then when she come back, right, she tell us it's because the kids in her form class then like one of them takes one
So why?
but then I end up hitting the teacher. Then GG had to rest at home.
Alamak, sec 1 so crazy.
Don't go. This generation
Worse.
I tell you, cannot
Don't go my school.
then 开架打架or the they sell all the weird stuff like
Then anyone smoking and vaping?
confirm will have but we just don't know.
My school a lot.
A lot.
All the neighborhood school is GG. And the smart one I think also got like
God, Chucky got.
Should have.
oh yeah. Got one time right, my friend minding his own business. He go Barca. Then a group of Chongqing high issue students come up to him. Wow, then like, hey, fashion I cannot. Don't say in Singapore. Wow. Then he damn angry. But he never do it.
Oh, so crazy.
Yeah.
He should have crazy.
Siao.
He should have never have known people and
You should got one time a man like go march in the middle of the road. Like march and properly march
You saw
on the news.
Oh,
Rainy days. Rainy days.
Hang on, is it Austria? I think it's Austria.
Max is 5, right?
Yeah, 5 is on top.
Mm.
I fit it in. Can lah.
Okay, if you don't need the extra space, then that should be fine.
Need
11.
extra space? Need extra space?
No need, not for this question.
Yeah, okay.
But some questions sometimes need extra space,
To
right?
find the C.
Yeah, or yeah.
Probably practical.
Mm.
This is quite practical.
Okay.
I do my skill just now. Then there's no this.
Now should be doable, right?
Yeah. They said every 2 cm must label.
Mm.
I have this habit of not labeling the 2 cm because my chapstick doesn't say don't need for math.
Oh. But makes sense, 2 cm is one big square, man.
No, 1 cm, sorry.
Or 1
I say 1
cm.
cm. Point 5 is 2. I don't need to do math.
Okay.
6 is 3.
Find the area under the graph, is it? Or parts?
8 times 7.
Yeah, the graph, is it?
Yeah.
Hmm. Calculate the distance of the ball bearing.
11.
Mm-hmm. You can, yeah.
You can. You
Mm.
mean there's another way?
Unless you want to do calculation.
Oh.
How long do you want? Oh,
1 meter will you. So you have 1 meter.
No more.
Oh, is it not supposed to be all connected? Oh my gosh.
Oh, you used to have.
That's the longest I have.
Take this back.
Okay.
Is it?
Hmm?
You take the unit piece.
What I
Joe,
use it for? It's 1 meter, yeah, 1 meter.
it's very good.
I can't remember what I use it for.
Primary school and
Yeah.
when the secondary school don't.
Is it?
I think you scared student, right?
No. It's for something else, for research. I can't remember exactly. Oh, measure like depth of the river, stuff like that.
It would.
No, metal.
Ah.
Metal is very dangerous, like stop like that one.
Then don't measure lah. Use your eye and see. Don't get struck. Later I measure halfway at the sun.
You have to measure the depth of the stream.
So what? You all take precaution when rubber boots.
No lah. I mean, yeah, they do. The students have to wear rubber boots.
Students.
Mm.
What are you saying? They make students do it.
Oh yeah, student project.
Thank you, Joe.
Oh yeah.
Go get strike on the uniform.
I'll get the average speed of the floor.
No, usually they will get out of the place. But that one time they were walking the canal, then it was raining. I think it was started to rain, and then water level rises very fast. No?
Right.
At first only at ankle level, then about 10 minutes later at knee level already.
No, I cannot lightning strike.
No. Luckily not. They were very smart. They quickly escaped.
It depends against time, right?
Yeah, against time. Make sure it's against time, otherwise you cannot calculate the area.
Against. So time is the x-axis.
Yeah, it's always the x-axis.
Oh.
In fact, for almost everything is the x-axis. I have never seen time being used on the y-axis.
Yeah, I draw.
Unless for
No.
primary school, only primary school.
Primary school now.
Yeah, they don't care at primary school.
So,
Times.
you know how much I stopped on PSIE for science?
How much?
You guess, Joe.
AL5. Oh, but your time no AM.
No, science.
You mean your what? Your
Grade,
marks,
grade.
your grades. You mean A, B, C, D?
Yeah.
Hmm?
You guess.
You surely can get B at least.
I got a C.
C.
Hey, doesn't matter.
I'm not kidding, Joe.
It really doesn't really reflect.
But Yes, he can only go to that school.
Yeah.
She's doing so well now.
Oh, yeah.
Ah,
I'm not doing very well now. I'm just saying.
failing like chemistry.
Only kind of school is your paper is hard.
Ah, yeah, the chemistry.
Oh,
You agree that it's hard.
which one? Chemistry?
Ah.
Yeah, it's quite hard.
Oh,
It's harder than O levels.
but that's no, actually it's good that it's harder. So if O level, so I won't be shocked by the O level.
Oh, but your father is worried.
Like,
Oh, okay. Before I forget, your part C, that one is tricky, you know.
also cannot use
Yeah, you cannot use the area.
So
You have to figure it
button.
out. That one is tricky. You may want to put an asterisk in case such a question come up. It's an unusual question. I tell you, I said tell you.
diagram.
Yes, you use a graph.
Hey, graph or diagram.
You use your graph. You use your graph. So very simple. Your graph should be something like this, right? Right, something like this. How did you draw a graph? Okay, fine. So the trick is continue the graph all the way to your y-axis.
0.
Yeah, at time 0, where is the distance
It's also continue drawing like that.
for part C?
Oh, then you find.
That is the trick. So try to remember that in case it comes up.
Then
That is the trick.
Well,
let me try.
I want to ask them. Holiday got revision class. No?
Oh, you want? Let's have it lah. Then does she want or not?
Okay.
Chemistry,
Both.
Both
Huh?
can.
Both.
Okay.
both chem and physics.
Yeah, obviously.
Oh, I thought you're very confident in your physics one. No.
Do you see I go at physics, sure? Where?
Okay. Then okay. Then I'll check with Zayden, see whether he wants or not.
Oh,
It will end up in 2 again. 0.5, yeah.
Oh, but must, of course, I have to invoice your mom again a bit more. Like that means I have to invoice your mom.
Okay.
She said okay.
Oh, I'm so happy that I'm ready to come back to tuition.
Oh, but when are you all free mostly for this holiday? Second, third week, right? I think.
yeah. Yeah.
Every space.
The first week packed.
It's Saturday and Sunday.
This week, weekdays cannot. The first week and last week.
Oh, okay. Saturday, Sunday is fully packed anyway. This place also no room for you on Saturday and Sunday.
Really?
Yeah, it's all the classes are used up.
Not really. We want to come back on our normal time slot.
You're coming back in your normal time slot anyway. He's asking for extra class.
Yeah,
What's extra?
yes.
Second and third week probably weekday.
Can we have it on juice?
Any day or
Any
Thursday
day.
afternoon. About.
Wait, let me check my. I'm
I
very
write down.
busy.
Come, Jingjie, you write down the dates that you cannot.
Every Thursday.
Sure. I almost everything cannot.
Every day cannot.
Wait.
Shit. First week packed. Second week I free.
Second week,
First week and last week.
For you, second week, yeah, available except for every day, weekday.
Yeah, okay. Then Thursday no. Not Thursday.
My one is
Third week also.
Third week also every day.
Yeah.
What do you say about Thursday?
Okay.
Not free.
Ah.
Afternoon or whole day?
Afternoon. Okay.
Not free. Okay, for second and third week.
Yeah, last week I don't want to anything. Sure.
Except Thursday afternoon.
I is except Tuesday night 7:30.
No. This is the except means she's not free.
Ah.
So for you, second and third weekday, okay.
Except for Tuesday.
Tuesday night.
So you can have it in the morning.
Okay.
What? Don't wake up.
No, it's okay 11 like that. It won't be that early one. Okay, so weekday is free, yeah?
Pick up early.
Except Tuesday night.
Actually, preferably not Monday also. If can.
Yeah, very hard. Very hard. Then I have to say them.
Hey, shit, what's in text error?
You have it in the morning, I don't mind also.
Mm.
Like early after the morning, first you
You're free also, right? You be what?
I'll be waking up at 7 a.m.
Oh, okay. Okay.
Grind.
Good on, good. You really got to revise for your exam. Better than what? Bio. Oh.
Huh? Like that. My friend who and the one that not doing a combined side.
Actually, what do you think? If you go combine, can we get higher marks?
Of course.
Sure. Sure.
I look at the people.
Confirm.
Maybe I should just not take a pure marks.
Yeah, too late to say that, right?
Oh, they register everything.
Yeah, long.
Change.
No, cannot.
Why? Jokes.
Because if you take combine, you probably can get A1. Probably. Yeah, just do what you can.
How should I be nice? I need chance I can. English you cannot revise.
English you have to how to revise.
And then one day should
Wait, see.
Can probably.
Sure.
Read the what? Textbook. Yeah, no, but you should be like her also write down notes, man. You need notes, man.
I don't know. I hate writing.
You have to depend on it one day, very soon. No, not say one day, very soon. You think you have the time to reread your textbook? No way, man. No way. I mean, don't tell me you only want to read once and then that's it already. Not possible, right? But you also don't want to reread your textbook. How many times do you want to reread? Twice. Twice is a lot of time also. But that's why you should try to learn write some notes. Speed read. Also easy.
It's so shit. Oh,
For chemistry, definitely we can write notes. Constant. You see a straight line.
Constant.
You mean part E, is it? No. Okay, it's part E. What was the acceleration of bearing as you roll along BC? No, what happened at BC? BC is the horizontal portion. So what kind of graph did you get?
What? The speed.
No, look at your graphs that you have drawn. It's a straight line, right? Straight line means what? Constant what?
Speed.
Yeah, we have to be a bit precise because it's distance time. So that means constant speed. Because distance is a vector. I mean, it's a scalar. Speed is a scalar too, right? So constant speed means what? Yeah. That's all.
Acceleration is 0.
Yeah.
As
speed
is constant.
acceleration as the rate of
Rate of change of speed.
Plus acceleration is 0 and speed is constant. Okay.
Is that negative acceleration? Which is acceleration.
It means deceleration. This is a negative gradient on your speed time graph or velocity depth graph.
Mentally active going up there, going down to the slope. Even at T,
Okay.
the radian of the stopwatch was 30 seconds. Calculate the deceleration of the ball bearing as it go up the slope. CD. So it went up T and then went down T.
Yeah. But in this case, they're only interested in the deceleration upwards. They don't care about the downward movement anymore.
So just see that.
Yeah.
My brain is not working now. 13 seconds at here. So you came here. It's the deceleration.
I drink coffee before.
Actually, drink coffee before.
No.
No, better don't try.
Then Milo.
Later your heart beats very fast.
And then be hyperactive.
Hyper, then you cannot think clearly as well. Hyper already.
Yeah, true. You know what they're doing?
I mean, what's the usual thing?
I just drink
Whatever usual. Milo is okay.
Milo.
You better try coffee unless you tried it before. You don't know the outcome. Yeah, you don't know because your body hasn't tried it before. You don't know what will happen. Or maybe you shake, you possible, no? Your hand will start shaking. Too hyper already. How?
Lazy thing.
Lazy to think, You calculate the speed just now. You did right, I think.
Yeah.
Yeah, you know the speed, correct?
Yes.
Okay, then
That's the initial speed.
yeah, then the final speed is it stops at point T, right? I think they mentioned that.
Okay. So it's like 0 minus 0.4 over 13.
No, certain because you're only interested in that. Remember where do you have deceleration? Only when it's going up the slope, right?
Yeah.
So what's the time from the beginning of the slope to the top, the top maximum highest point?
5.
No, not 5. You do know. Let me see, where is it? Where's the 11? Distance from B is 11. What happens at 11?
So CD.
Yeah, okay, look at this.
13.
Yeah, look at 11. I mean, at this point. Come in, team. Here. At point C, this is 11 seconds. Right, then it stops at point D.
So it's 2 seconds.
Yeah, it's 2 seconds. It's 13 seconds.
So it's 13 minus 11 divided by 3.
What's the formula? A equals to B minus U.
I mean like the time. 2 seconds.
Yeah, it's 2 seconds.
So it's negative 0.2. That's all?
Yeah, that's all. That's all. But you must know how to process all the information.
Okay, this area is 0.2 meters.
Mm.
So no negative.
No, because they use the word deceleration. So that's the tricky part. Okay, good. We'll go through the answers next week. Right. Inertia. What's inertia?
I remember got
It's something like weight.
A few things. Inertia depends.
Ability to something stops the weight of a thing. Ability affects the motion. Wait, the weight affects the motion of something.
Okay, let's not talk about weights. Inertia is more about mass.
Okay.
Right. So the higher the mass, the greater the inertia. Basically, inertia is okay. It's the tendency of an object to continue with its motion. So, or okay, let's rephrase it. Inertia is the resistance of an object to change in motion or to start moving when it's stationary. So that means if object is stationary, it has a resistance to being moved. Okay? Or if the object is moving already, it has a resistance to being stopped.
Oh, so right, that plain example in our theory, the they remain because of inertia.
Yeah, because in plane virus flying like that now. So if you're in the plane, you tend to also continue moving like that. But the plane doesn't continue like that. The plane goes down, but you still moving like that. So of course you're gonna hit the ceiling.
Oh, so I feel like we'll come up with questions.
Maybe, maybe.
How big is the ceiling?
You hit the ceiling,
You hate GG,
yeah.
Wait, first.
First, no, but it's gonna be quite seriously injured.
not concussion.
Okay, not just that. After it hits the ceiling, you'll probably still fall down at the end. And then that's when you injure your spine or something.
Break my
Break your leg, not too bad, but don't break your spine.
Even the ceiling fall down.
Yeah, also.
I do.
Actually, the aeroplane are quite poorly constructed, no? The luggage at the top, it seems like it's quite easy to break and then fall down.
on you.
Yeah, for you, imagine how heavy. People put, I don't know, 10 kg up there.
Your neck will break.
Probably,
Crazy. Thank you.
yeah, I can imagine if they can put 10 kg up there. Not that heavy, but if it falls on your head, it's still terrible.
Okay.
But they say 5 kg at most,
Are you sure?
but can be on the plane.
I think it's more than that. I don't think it's 5 kg. I can't remember the number. Maybe 8. I don't think it's 5. It should be more than 5.
I mean, ask my mom tomorrow.
Oh, okay.
Bye-bye.
Bye-bye.
I don't know what to do, but Chang.
Myself sleep early. There's nothing you can do, right?
True.
Okay lah.
Okay, good luck. Bye. So insurance. What's your school teaching now?